All right, so this is the last lesson in the entire trigonometry unit. Again, unit 1, which covers half the course, and unit 2, which covers a few lessons, are in complete contrast to one another in many ways. And so this very short unit is coming to an end, and really this lesson is just looking at just a few more applications of these things, but there's no new concepts here. And so the first thing we want to remember is what sine, cosine, and tangent represent. And they're all ratios. The sine ratio is, from any angle, is the side opposite over hypotenuse. The cosine ratio is the sine adjacent to the angle divided by the hypotenuse, and the tangent ratio is always the side opposite from the angle divided by the adjacent side. And a common way to remember this is to remember SOH, CAH. I'll make these more colorful because that really matters. SOH, so, ka, toa. It's funny that people remember that so, ka, toa, because it doesn't actually make any sense, but it kind of works. And since these are ratios, they're fractions, the order you divide, the order of the ratio matters. So you have to remember sine is opposite over hypotenuse, not hypotenuse over opposite. However, really trigonometry began back a few years ago with the Pythagorean Theorem, and the Pythagorean Theorem, never want to forget, anytime you have a right triangle, a squared plus b squared always equals c squared. And as well, going back even earlier than that to elementary school, if you look at any triangle, doesn't matter what kind of triangle it is, if it's a right or non-right triangle, all the angles inside the triangle always add up to 180 degrees. The sum of all angles inside any triangle. All right, so these two phrases, angle of elevation and angle of depression, are a way of describing a particular angle. And so they all have to do with, in essence, some sort of starting point looking. And imagine here's a person, here's a stick figure, and if they're looking up, that's, towards some object up there, what I'm drawing in red, that is what we call an angle of elevation. If they're looking down, it's the angle of depression. If you're looking straight ahead, that is neither. And so if you're looking straight ahead, that's a 0-degree angle. If you're looking straight up, that's an angle of elevation of 90 degrees. If this person's looking straight down to their feet, that's an angle of depression of 90 degrees. And really, this is when we're trying to describe a particular angle in some sort of scenario, we need to be clear about what these two phrases mean. And it's really easy to misunderstand, but again, it all comes back to just imagine you're looking at something. If you're looking up, it's always a measurement from the horizontal, what I have labeled at 0 degrees, up. If it's an angle of depression, it's from the horizontal going down. So those arrows matter as well. And this visual hopefully helps. So with that said, I don't need lots of examples. First, let's solve this right triangle, which means let's find all the missing measurements. So what are all the missing measurements? There's two angles we don't know. There's an angle there, there's an angle there we don't know. There's also one side we don't know. Okay, these are all the things we don't know. And I'll just call the first one, I'll call this A, I'll call this B, I'll call this C. So solving a triangle means to find everything we don't know. In this case, there's 3 things we don't know. A and B are angles, C is a side. There's always countless ways of doing this. I can start with any of these. I'm going to start with finding angle A, because A is the first letter in the alphabet. But I can do anything I want. Okay, so to find A from that angle, what do I have here? Well, from that angle, I can see 6.99 is the hypotenuse. Right, the hypotenuse I can see is opposite across from the right angle. So I know 6.99, almost 7, is the hypotenuse. From angle A, 5.77 is opposite. It's adjacent to angle B, but right now I'm trying to find angle A. So if I want to find angle A, if I want to use those two sides, opposite and hypotenuse, I want to use the sine ratio. So over here I can say the sine of A equals opposite over hypotenuse. In this case, 5.77 over 6.99. Okay, thinking back to what we saw last day, I can now find A by using the inverse sine ratio. A must be, that's a highlighter. A must equal the inverse sine of 5.77 over 6.99. Now clearly, if we didn't work with the last lesson very well or very much, there's no point looking at this video very much. I'm assuming we've seen and practiced some of those things from the last lesson. And so then I go to my calculator, make sure it's in degree mode, and the inverse sine of all of this comes to about 55.6. So I'll round it to the nearest whole number. I'll say it's approximately 56 degrees. So that angle there is 56 degrees. Okay, that's one of the three things I want to figure out. Now I need to find either B or C. I'm going to find B next, not just because it's next in alphabetical order, but because I can now find out B really easily. How is that? By remembering some grade 6 math, and that is all angles in any triangle, 90, the one we just found, and the one we're trying to find. All those angles together always add up to 180 degrees. So I can use that fact to find B really easily. I know that angle B must be the same as 180 degrees, take away the 90-degree angle, take away the angle we just found. Because again, all three angles in any triangle add up to 180 degrees. And so let's just do that, and then I'll have B. I'll be done. I don't have to use actually any trigonometry, like any of the ratios. So 180 minus 90 minus 55.6 rounds to about 34 degrees. I say rounds because that 56 degrees really was, I rounded, right? The 56 degrees I found right here was not an exact value. I rounded to the nearest whole degree. There, I've now got two of my three unknowns found. So all that's left is to find C. And I have many choices. Just for the sake of variety, I'm going to use the Pythagorean Theorem to find C. Going back to grade 8, anytime you have a right triangle with two sides that you know, you can always find the third using the Pythagorean Theorem. So to find C, I'm going to use the Pythagorean Theorem, but be careful. If I just write down a squared plus b squared equals c squared, I may mix up that c with that c. Keep in mind, in the Pythagorean Theorem, this c right here represents the hypotenuse. Hypotenuse is 6.99. I know the hypotenuse. A and B are just the other two sides. I can't get too hung up in the exact variables, right? So for this, I'm going to, I know 6.99 is a hypotenuse. I know 5.77 is another side. I'm going to say c squared plus 5.77 squared. Actually, let me just make this a bit neater. So c squared, take 2, plus 5.77 squared must equal 6.99 squared. Because again, the Pythagorean theorem states that the sum of the shorter two sides squared always equal the hypotenuse squared. All right, like I said, please don't be hung up on the Pythagorean theorem. The c has to be the same variable you see right here. The c in the Pythagorean theorem, a squared plus b squared equals c squared, is the hypotenuse. And maybe I'll even reference that right here. Right, that there is the hypotenuse. Other two sides, doesn't matter what a and b are, as long as c is the hypotenuse. All right, so this step, that means if I, for example, if I just subtract 5.77 squared from both sides, that means c squared must be the same as 6.99 squared minus 5.77 squared. I'm going to go to a calculator here, and if I type 6.99 squared minus 5.77 squared, I get 15.5672 approximately. However, that's not c, that's c squared. And so to find c, I need to square root that. C equals the square root of my answer up above. And that comes to about 3.9 centimeters. Actually, no, I have no units here, so just 3.9. My original question has no units. So now I'm done. If I look at my triangle, a missing side is about 3.9 units. The two angles are one's 56 degrees, one's 34 degrees. All right, before I go on, I could have done this in a different order. I could have, I didn't have to use the Pythagorean theorem here. I wanted an example that kind of showed all three of the things I mentioned up here, right? Trig ratios, Pythagorean theorem, and the sum of all angles. All right. So I believe I have just one more example here. Yeah. So an example like this is always going to be one of the more challenging parts because there's no diagram given. So we have to be able to read this, understand the terminology, and visualize what's being described. All right, so you live on the 15th floor of a condo, which means your apartment is about 150 feet above the ground. looking out from your window at a neighboring high-rise, your eye is making angle of depression of 71 degrees to the base of the high-rise and an angle of elevation of 63 degrees to its roof. How tall is the other building? All right, so first of all, please don't expect to read that once and then have a great visual. Let's start by making, a quick little drawing here. I have the ground. You're in a tower, so you're on the 15th floor, so you're about 150 feet, it said. Okay, I'm not going to put units here, but that's your height of you to the ground. So you, I'm going to show as a red dot. Okay, now our tower, the tower you're in, probably goes up higher. Doesn't really matter though. All that matters is you, right here, you are 150 feet above the ground. Okay, you're looking out towards another tower. So I'll draw another tower here. So this tower, it says, that first line, looking out from your window, your eyes making angle of depression of 71 degrees to the base of the high rise. So what does that mean? Well, that means looking out from your window at the other high rise. Your eyes making angle of depression of 71 degrees to the base of the high rise. The base is down here to the bottom. So that line I just drew in red, that's how far you're looking down. So where does a 71 degrees go? It goes right here. This right here is 71 degrees. That is the angle of depression. If you're looking down at something, 71 degrees, that is my angle of depression. That's where the 71 degrees goes. Okay, so similarly, it also says when you look towards the other building, your eyes make an angle of elevation of 63 degrees to its roof. So from that same point to where you are, let's imagine you're looking now up to the roof. So where does that 63 degrees go? That goes right here. That's this angle right there. And again, everything I just described, angle of elevation, angle of depression, goes right back to what I had right here. Right, angle of elevation is always from the horizontal up. Angle of depression is always from the horizontal down, always. Depends what we're looking at though. So with that said, what's the question asking us to find? How tall is the other building? So how tall is this building right here? What is the height from here to here? All right, that's what I'm trying to figure out. In many ways, the hardest part of the question, or one of the hardest part of the question, is now done, which is visualizing what's taking place here. So how do we figure out that height? Well, in fact, actually, I'm going to erase the x, because that implies I should be able to find this necessarily in just one step. But I'm trying to find that height of what's been highlighted there. So how can I figure this out? Well, now that leads to the next part of the problem, kind of breaking this up. One thing I can figure out right away is this distance between my two buildings. I'll call this y. That distance from here to here. I have enough information to figure it out. How do I have enough information to figure it out? Because that 150 feet is also the same distance from here to here. Right, that distance right there is 150 feet. And so if I look at this triangle that's in red, and I'll even draw it all in red, I have a right triangle, right? This must be a right angle here, assuming the buildings are standing straight up, which is, I think, a fair assumption. That triangle in red, I now know it's a right triangle. It has a 71 degree angle, and the side opposite to 71 degrees is 150 feet. And so I can now find y. And I can find y using the tangent ratio. Because from that 71 degree angle, I know the side opposite to it. I'm trying to find the side adjacent to it. Opposite and adjacent is tangent. So let's do that. So I can say the tangent of 71 degrees must equal the side opposite to 71 degrees, which in this case is 150 feet, divided by the side adjacent, which is my y, which in this case represents the distance between these two buildings. Okay, now I can cross multiply, right? If I make this over 1, I can figure out y by going 150 times 1, dividing by the tan of 71. So y must equal 150 divided by the tangent of 71 degrees. Type that into your calculator, and you should get about 51.6 feet, which remember, we want to always think about what this stuff means. That is how far apart the two buildings are. The two buildings are about 51.6 feet, roughly 52 feet apart. All right, so what do I do with that? Well, if I look back at my diagram now, I can now go to this y and say equals about 51.6. And now I can look at the triangle in green. If I look at this triangle, I can now find the height of this triangle, which I will call x. I'll call that x actually. Because I can now see, once I know what that height of that green triangle is, I can just add that to 150 and I'll be done. I'll know how tall this building is. So now looking at this green triangle, which again is a right triangle, how do I find x? Well, from 63 degrees, x is opposite. But I also now know the width of this triangle. I know the adjacent side is 51.6. So like before, I can use tangent again. I know from 63 degrees, I know the adjacent side. I don't know the opposite side, but I can figure it out. So now over here, I can use tangent again. And I can say the tangent of 63 degrees must equal the side opposite to it, which in this case is x, divided by the side adjacent, 51.6. All right, and now like before, I can cross multiply. I can find out x really quickly. In this case, all I have to do is go 51.6 times the tangent of 63, and I won't have my final answer. I'll have x, so we got to remember what x stands for here again. And so x equals 51.6 times the tangent of 63 degrees. Type that into your calculator, make sure it's in degree mode, and you get about 101.3 feet. So what did we figure out? 101.3 feet is this region I'm highlighting really brightly right here. It's how much higher the roof of the neighboring building is from your apartment. And we know our apartment is 150 feet, sorry, in height. So I just got to put these two together. The neighboring building must be 150 feet plus 101.3. And so let's do that now. So therefore, the total height of the building must be 150 feet plus the height I just found, 101.3 feet, which comes to about 251 feet. I'll just round to the nearest whole number. And that's how tall that building is. So notice, this is a tough question. This is as tough as things get in this unit. So I would not be surprised if you found this challenging. And it's challenging for many reasons. First of all, I didn't give you a diagram. If I gave you this diagram here from the start, the question's not easy, but it's a lot easier. You don't have to, you don't have to be unclear about what some of your measurements are. Although your job is to understand these descriptions about angle of elevation, angle of depression. I can't answer those things on a test. So that's the first hard part. Then it's like a puzzle essentially. In this case, okay, with all this information, how can we figure out the total height? In this case, we had to first find the distance between the buildings. Then we found out how much taller the other high rise was compared to your apartment. Then we add that to the height of your apartment. So 3 sort of steps after we had it all set up. A tough question, but it makes sense because it's the last lesson in the chapter. So I don't want to start with something, I don't want to end off with something that is too easy. All right, so I'm going to stop here.